Will the kids, no problem. Yeah, thank you. Yes, can you able to screen now? Please reply me.
Yes,
Yes, sir.
yes, sir.
Yes, good. Yeah. So come back to the lecture. So there are about 34 students. Fine. So good. So last week we have discussed about step one, right? So step signal, which is here, This is step signal, unit step signal. Okay. So in that class, I have explained you that. So this step is much useful to us in regular applications, and one application which I have given to you as the what it's called stabilizer, right? It will continuously provides a common one. It will provides a continuously of a common type of mm, continuous equal amplitude signal, which will help us to use in nowadays. So I have drawn a figure. You may remember this is a figure which I have drawn on yesterday, right? This is a figure which I have drawn yesterday, and this I said is 1. So this may not be 1. If it is 1, I can call it as unit step. It is not 1, I can call it as simply step. If it is some 4, right? If it is some 7, otherwise we can call it as step only, not unit step. Okay, more than 1 means it is not unit step, it's step. Unit means 1, that you know. Okay, so can you able to see my video, ma? Someone please respond.
Yes, sir.
Yeah. Right. Thank you. So in this nowadays, whatever mobile phones, whatever TVs, and whatever electronic gadgets, what you are using, so all are using this type of power supplies. All are using this type of power supplies, and this will sweetly will call it as DC. Okay, this will call it as DC. So we'll call this as DC power supply. So because there is, look at in this case, what is the difference between this and this? This is called AC. This is called AC, alternating current. Okay, AC current or AC voltage. And this is direct current or DC voltage. In this is positive and this is my negative. Right.
Negative.
Yeah, very good. So what is the problem with this fellow and this what is the problem with this fellow, ticket fellow, this blue ticket fellow? What's the problem and why I am using this one? Simple. So look at here, what is the voltage approximately here? It will be 0, right? And what is the voltage here? 0. What is the voltage here? 0, x-axis, right? And here maximum value, let it be 2 volts, and here minus minimum value, that is minus 2 volts. So again plus 2, minus 2.
Nine.
So in this, look at here, 0, then 0 0.01, 0 0.02, 0 0.03, so on, 2, again 1.9, 1.8, so on, 0, minus 0 0.1, minus 0 0.2, so on, minus 2. Like this, what happened is, right, if you're right, see this, up and downs, there are up and downs, okay, means continuously fluctuating. So this type of fluctuative behavior will create effect on system performance. It will create effect on system performance. That is the reason, right? That is the reason we don't prefer these digital, sorry, analog supplies. We don't prefer this digital supplies. Okay. Now, so yes. So in this, yeah, in this what digital power, there are no fluctuations. In this digital, there is no fluctuations. Only straight signal. Only straight signal. So this will make the system to be function with a smooth, right? There is no up and downs. So fluctuate was awesome level. This is called DC power supply. Right. So, can anyone tell what is regular power supply which you are using in nowadays in our regular home application? So, what is the power supply
AC current,
of a
sir.
power supply of a fan? How
AC
much you are
current.
using? Yes, AC. How much, Nana? Sharat, Bharat Chanda. What is the
240.
value of it? What is the value of it?
But whole current is 230 volts, sir. Incoming to the house. I perfectly don't know, sir.
Yes. Okay. No issue, Nana. I'll clarify it. Okay. So, what is the
Okay, sir.
voltage we are using nowadays? That is a pure sinusoidal in our regular days. మనం ఇంట్లో వాడేది in our houses, whatever we are using, it is the alternative current or AC current, right? So this will be right around 220 volts to 240 volts. It is around, I'm telling. Okay, 220 to 240. That may be varies based on the various circumstances. Okay, so 220 to 240. Right. Not maybe you don't know. When I was a kid, when I was a school days, there may be dim in the old days. In nowadays, even in the some villages, your parents will say current dim gostundi, power dim. So that is right. Voltage amount is less. Right. So voltage amount is less. Sometimes it may not be 220. It may be a 180 also. That depends on various circumstances. Okay. So for for regular applications, we are using this. And this is only for alternating devices such as fan, AC, bulb, okay, and coolers, motors. For that only, all electronic gods, yes, this 220 volts will be down. This 220 volts will be converted into 12 volts. This 220 volts will be down converted into 12 volts, and are that 220 volts again further down converted into 3.4 volts, 4 volts, 5 volts. It depends on applications. My mobile phone. This is my mobile phone, right? Can you able to see my mobile phone? Hello, can anyone respond? Can you able to see my mobile phone?
Yes, sir. Yes, sir.
Yes,
Yes, sir.
in this mobile phone, right? When I was purchased, there is some specifications at the back side of it, some specifications on the box. So they clearly mentioned here somewhere. Look at here. Here, this some have they mentioned. What they mentioned here is it was operated at 3.4 volts. It was operated at 3.4 volts. So according to that, I need to use the adapter. So this is adapter. Okay, can you able to see one? This is charger. This is adapter will call. So this device will convert 220 volts, which I applied here, 220 volts to 3.5 volts. Output from here, I'm using this digital device. Okay, this is a cable. Okay, charging cable. I'm using this cable, and this is the adapter. This cable will be plugged to the mobile phone, and output of this will be from here is 3.4 volts. Okay, that will be done by this one. That will be done by this one. Right. So every electronic device, right? Even so, can you able to see one more? What is this? What is this, ma?
Laptop charger.
Right. This is called laptop adapter. Right. So until this wire. So until this one, up to this is 220 volts. Up to this is 220 volts. And this one, this adapter will convert this 220, right? It will convert this 220 to 12 volts. And this is 12 volts wire. This patla wire. Okay. This thinner wire is to 12 volts. And that 12 volts DC, I am applying to the laptop. Okay, so all electronic components are working on this DC power supply, right? So can you please tell me specifications back? Okay, I'll come back to the topic. So what is the specifications? Right, so specifications means regularly we are using 220 volts, right? 220 to 240. This is called voltage. Right. Along with this, there is some current. Along with this, there is some current. That current is called 10 amperes. 10 amperes. Right. Do you know this 10 amperes?
Yes, sir.
Right. Very nice. So 220 volts, 10 amperes. And the one more beautiful point is called 50 hertz. What is this 50 hertz? 50 hertz. Hertz is nothing but frequency. This is a sine wave, right? Yes, this is a sine wave, right? We told this is a pure sinusoidal wave. So for this sine wave, there is some frequency, right? And that frequency is 50 hertz. That frequency is 50 hertz. So this is about our AC signal. Can you please tell me what is the? Can you please tell me what is the right? So 38 participants. Please someone take a screenshot, ma. I'm not able to see them. So please someone take a screenshot and share me after the class. Yeah, please share me after the class. Right, ma. Thank you, Shreya. Right, because in my laptop it's difficult to take screenshots. So I need to go to paint and all. Right. Thank you. So this is my What is the frequency? I told this is a DC signal, right? It's a DC signal, and voltage, right? Voltage, I'm giving it as some 5 volts, right? I'm getting some disturbance from someone, right? Bharat, mute Nana. Thank you. Yeah. So this is 5 volts. Can you, and I'll tell this is 5 volts, right? Can someone tell, right? Can someone tell, please mute your mic, someone is talking. Yeah. This is 5 volts, right? This is 5 volts. And can you tell me what is the frequency of this?
0 hertz,
Zero.
sir.
0.
Fantastic.
Zero
So
hertz.
yeah, exactly. Because this is not repetitions. This is not repetition. It is a single pulse. So it will be extended till infinity. Right? So in this case, the time period is infinite, because it is continued till the end. So in this case, time period is infinity. What is the frequency, Nana? Frequency is 1 by t. Right? What is a 1 by infinity? 1 by infinity, how much? It's a beautiful 0. It's a beautiful 0. So frequency of a DC signal is 0. Right? Now, so this is about a signal called unit step. Now, I'm moving to the next one. Very, 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 very important. Right? So, unit impulse. Unit impulse. And this unit impulse is very much useful to us, right, in real-time applications. Right? So, the speciality of unit impulse will be like this. Right? This is a unit impulse. This one. This is a unit impulse. So it is defined at only 0. It is defined only at 0. At rest of the points, it is 0. Not understood. Right? It is defined only at the origin point. And except origin, the signal value is 0. Right? So here you can able to see one example. This is an example. Right? So look at here. At R is in only, it is some value. It is some value. This is a value. Right? Except origin. What is there any value? Is there any signal? No. So this is called unit step, and will know generally present with del of n. So this is also delta. You know delta? This is called del. It's called del. Okay. So this del of n. So it is a discrete type representation. I'm calling it as del of n. I can also represent this as del of t. Del of t. Del of n is there. Del of t is there. Both are same, and both are impulse. Sorry, what is that? Impulse signals only if the height, if the amplitude is 1. If the amplitude is 1, then it is called unit impulse. Unit impulse. Impulse, Nana. IMPULS. Impulse. What is the meaning of impulse? Can anyone elaborate me what is the meaning of impulse? What is the meaning
Large
of
force acting for a short interval of time.
Nana, malokasari.
Large force acting for a short interval of time.
Excellent. Superb answer. So, a large force which is acting for a short interval of time. So, very nice answer by Sai Suresh. Thank you, Nana. Very well. So, now, can you please give me a real-time example why I am studying this? Real-time example. Can anyone? I'll give you 10 seconds. Anyone? Real-time example. Short time low, huge energy or force.
Kicking football.
Kicking football. Right, good answer. Tarak Prabhu చెప్పింది good, Nana. Next. Right. So the best example.
Jerk received by the bike driving, sir.
Yes.
Jerk received by the bike driving during the speed breakers.
Yes, but that is small amount only. Okay, small amount also we can consider. So I am expecting huge in short time. Right. So that I'll explain you. That I'll explain you with a beautiful example. You know thunderstorms, urumulu in Telugu. Thunderstorms. Right. So one of our CSC friend, right, he passed away due to this thunderstorms. Okay, CSC second year, Lingaya. Right, we helped them also. So this thunderstorms is one of the best example for this unit impulse. So how much time this thunderstorms will comes to earth? మనకి ఎంత సేపులో కనిపిస్తుంది? इतना टाइम लगेगा हम ऑब्जर्व करने के लिए. Can anyone able to observe the thunderstorms for a half an hour or 30 minutes, at least 2 minutes, 3 minutes?
No, sir.
No,
Not
sir.
at all possible. Not at all possible. Right. So it will be happen within fraction of seconds. So that fraction of seconds I'm calling it as now, that is or is in 0. Will it happens after that? No. Will it happens before that? No. Somewhere again happens, but not this one, right? ఇంకొక దగ్గర ఎక్కడో జరుగుతుంది, but ఇది కాదు. Right? That is different. Right? So the thunderstorms, urumulu in Telugu, I don't know in Hindi. So this is the best example of this unit, impulse sequence or signal.
Well,
Right. So if the height, right, if the height, that height is 1, then I can call it as unit impulse.
simple.
Okay, unit impulse. Now we'll see the definition of it. See the definition, del of t, right, is equals to, right, 1 or 1 for t equal to 0, for t equal to 0. Right, here I'm taking t, so I'm using t. I'm representing in a continuous format. Okay, so, and this is 0 for t not equals to 0. Right, one point you need to remember, impulse, unit impulse, there is no discrete and there is no continuous because it available only at 0. It is available at only 0. So it is available at only one point. How can you say it is discrete? Not correct. But, right, but I can represent like this. See this stupidism. This is called stupidism. Right. So what is stupidism? Then stupidism another self-satisfaction. This is called self-satisfaction. So I am arguing that this is not a discrete because it is existed only one part. So it is not discrete. But someone, I don't know who is he, I'll take Sai Suresh. Sai Suresh says, sir, why don't I represent like this? It is existed at only 0. I'll put other zeros. Look at here. This is 1. Their value 0. At 2 value 0. At 3 value 0. At 4 value 0. Minus 1 0. Minus 2 0. Minus 3 0. Now, while observing this figure, is it a discrete or continuous? It is like looking like a discrete. So Sai Suresh says, sir, it is discrete. But I says it is exist only at 0. How can you represent others? No need of representing zeros, na? So some ambiguity in between these two, right? Compare these two statement. So what I want to tell you that both are same, both are existed only n equal to 0. And this impulse again we'll discuss after few days because it is having some peculiar applications and which are very much useful to us in upcoming classes. Again, I'll come back to this impulse signal in some few more classes later. Okay. So this is about the second most important one. Then the third one, right? Exponential. So this I have shown already. So it can be represented in the mathematical format. So in the mathematical format, it can be represented as, so x of n equal to c into alpha power n. So see this, these all are various, right? These all are various, beautiful. Strength is 40 today, highest strength. Right. So 40 and Jasmita and 2 Jasmitas, 21, 22, 2 Jasmitas here. Right. So GTA Ambati batch, yeah. It's 2, 41, 42 people. Very nice. Good strength today. I'm expecting more. Right. Thank you. So see, this is one type of exponential. So I'll draw in continuous form. This is one exponential. Yeah. Tell me, is this exponential or not? Someone, ever okal chal. Yes or no? Is this exponential or not? Right. Figure 1 exponential or not? Someone please reply by looking. Same, huh? Hello. Can
Yes,
you able to, yeah. This one, figure 2 is exponential or not? Figure 2 is exponential or not?
No, sir.
No? Okay. fourth one. And the same axis I have represented. Now, tell me 1, 2, 3, 4. Which are exponentials? Post in chat box. Post in chat box. Ayo. So this is, let it be 1. This is 2. Three. Oh, yeah. Please, everyone, post in chat box. I think you have a chat, right? Post in chat box, right? Which are exponential? 1, 2, 3, 4. Everyone, I need answer from everyone. Pavani posted. Sujana and Sushma posted. 412 posted. Padma Priya posted. Chat. Are you able to get the chat? No reply till now. 1, 2, 3, 4. How many are? Which are exponential in this? By looking only.
4, sir.
Post, Nana. Post in chat box. You're not able to get chat box? You're unable to find chat box? Right, someone. Who's that? 21, 22. Okay, brother and sister said 2, 3 are exponential. Sai Suresh says 2, 3, 4. Right, next. Few more. ఇప్పుడు ఆన్సర్స్ తెలిసాయి కదా, ఏదో ఒకటి కొట్టండి. Right, Srikanth 423. Respond, Nana. Harshit saying 2 and 3. 48. 44, 2, 4. Padma Priya 2, 3. Jyoti 3, 4. Pavani 3. Yeah. Only these people got the opportunity to read out. The remaining, right? Chandrachari. Bharat Chandrachari. And reply 1, 2, 3, 4. Okay, 1, 2, 3, 4. Srihari, number 4. 2, 3. Right? Yeah, enough. Thank you for your answers. So, luckily, all 1, 2, 3, 4, all are exponential. All are exponential. But few names I want to give for them. Some names. Pet names I'll call. So, Mudu Perlu Anukondi, sweet name Anukondi, like a puppy, Chinni, Bunni, Bajji, Buji, like that. So, this one is called exponentially decaying. This pet name is called exponentially decaying. Decaying. Okay, this is called decaying. SCAYING. Exponentially decaying. And this one is called exponentially increasing. Exponentially increasing. So this is called exponentially decaying. This is called exponentially increasing. This also exponentially increasing, and this is also exponentially increasing. But the position is different. Positions is different. This one I started from 0. This one I started from some infinity, ending at 0. And this I started at 0, ending at some infinity. This is example of Corona. 3 is Corona. Right? So we are expecting 1. Corona, we are expecting 1 because nowadays in India, more than 340,000 cases. So this one, it should be reaches to 0, so that will be in safe. So I don't know how much time it will happen. This is time. So maybe 1 year, 2 years, you are complete 4 years of BTech or complete 50 years. We don't know. Right? It will be decided in future. Right? So this 1, 2, 3, 4 all are exponential, but like this. Okay. So any exponential which is increasing, any exponential which is increasing in this manner, any exponential which is increasing in this manner is called, right, exponentially increasing. Any exponential decreasing, it may be here decreasing, or it may be here, it may be from here, or it may be from here, or it may be from somewhere. Whatever, this type of downfall is called exponentially decaying. So there are four pictures. Look at here. This is exponentially increasing. This is exponentially decreasing. And this is also decreasing, increasing. Together, both are there. And this also increasing, decreasing. All various combinations we have. So this is these all are called exponential signals, and general definition x of t equals to some c into e power t. So in place of e, what is e? Logarithm lo e untundi kada, it is like logarithm e. So that e, in place of e you can also take c into some constant a power t, constant t. So this is also exponential. This is also exponential. So this is exponential of e, this is exponential of general. Okay, this is exponential of general. So this is in which I have drawn. This green color lines are continuous, this black color dotted lines are discrete, and this is a discrete representation is here. Look at this box. X of n equals to c into a power n or alpha power n. So this is a representation of exponential in discrete form, and these are the various expressions. Various expressions are equations for each and every. Look at here. Right. Yeah. Look at this one. X of n equals to, right, alpha power n, right, a greater than 1, alpha power n, alpha greater than 1. So put alpha equals to 1, 2, 3, anything, not one, many, only one. So take 2, Nana. Take 2. That should not 1 greater than 1 only possibility. So take 2. So if I take 2 power n, right, put n equal to 0, 1, 2, 3, 4, 5, 6, 7, etc, etc. If I put 0, it is 1. If I put 2, so it is 4. Right. If I put it is 0, at 0 it is 0. Right. At 1 it is 1. At 0 it is 1. At 0 it is 1. This one. At 0 it is 1. Okay. And then at 1 it is 2. At 2 it is 4. At 4 it is 2 power 4 means 16. Then 32. Then 64. So how is this shape? This green shape. Right? How is this shape? It's look like a beautiful, this blue color. Right? This is a beautiful, right? This is a beautiful, right? Yeah. This is a beautiful green color. This is exponential. This is a beautiful exponential. And this can be like this. This can be exponential, will be slow exponential. Exponential can be like this. Exponential can be like this. Exponential can be like this. Right? This is called slow increment. This is faster. This is very faster. That depends on the right powers. That depends on the power. Exponential power. Right? So this is an exponential signal. This is called increasing exponential. Look at the second expression. Right? Look at the second expression, this one. Right? X of n equals to same a alpha power n. Right? Here it should be that alpha is in between. Right? It is in between 1, 0 and 1. 0 and 1. So if I put a 0, 0 power 0 is 0. Right? If I put 0.1, 0.1 whole square is 0.1 whole square is, right? So what happened is when I put 0.1, 0.2, the value is further decreasing when the powers comes. So this is this one. This is a decaying exponential. This one is a decaying exponential. And in this case, so same alpha power n, but the range is -1 to 0. Only the range is factor. This is only the range. So this range also will beautifully called as ROC. Can anyone tell what is ROC? ROC. Right, ROC stands for region of convergence. Convergence means existence. So Z, region of convergence or existence. So this ROC, right, this is gives the in which range this is exist. So this is also one more expression. There are various, by looking onto the expression you can understand. There's no bigger Bernoulli equations or nothing. So it's very quite simple one. So this is about the next elementary signal exponential. So next, I want to move to the next few more, right? And that next one is called sinusoidal. It's not here, but I'll explain you. So you have already having some idea. So I'll take that and I'll explain you. One more elementary is called sinusoidal. Some people will also call as sinusoidal, right? ఎందుకంటే వాళ్ళ డాడీ పేరు అంట సీను అంట. So it is called sinusoidal. Right, some people are called sinusoidal. So that depends on their pronunciations. Right, so spelling will be common, that depends on pronunciations. This is called a sine wave or this is called a cos wave. Right, so this is a sine wave, this is a sine wave. Right, okay, so usually this height is 1 and this height is minus 1, usually I'm telling. Okay, so and if I want to express this equation, the signal in mathematical format, this can be, right, x of t or f of t, right, equals to some k or capital A into sine. Oh my god, this is a generalistic representation of a sine wave. In place of sine you put cos wave also, but waveform will be changed. Waveform will be changes. You know how is a cos wave? This is a cos wave. What is the difference? Can someone tell? What is the difference? What is the difference in sine and cos waves? What's the difference in sine and cos waves? Someone please tell me.
It is somewhat delayed to compare to sine wave, sir.
Right, analysis is correct, but not wording is not correct. చెప్పింది కరెక్టే కానీ చెప్పడంలో కొంచెం సరిగ్గా చెప్పలే, కానీ నీ థింకింగ్ ఇస్ గుడ్. సో ద డిఫరెన్స్ ఈస్ ఇట్ ఈస్ నాట్ డిలేడ్, ఐ కెన్ కాల్ ఇట్ యాజ్ shift. So phase shift otherwise. See, sin 90 minus theta, how much? Cos theta. Yes?
Yes, sir.
So the 90 degrees is a phase shift. That 90 degrees is the phase shift. ఇప్పుడు చేసింది నేను అదే, that only I did it now. So look at here, this is earlier. So can you tell me what is the value from here to here? This is pi. Usually we'll take this is pi and this is called 2 pi. Usually we'll take 2 pi. So what I did is I shifted this for some extent. Half of this means half. So look at here, from this point to this point, from half this point to this point is pi, then from half of it means, right, just a second, let me take another color to understand clearly. So from here to here it is pi, from here to half of it, so it is exactly half. So how much it is? Pi by 2. Pi by 2 is how much?
90.
Beautiful. So pi by 2 is 90 degrees. That only I'm telling. So sine and cos are just 90 degrees phase shifted, and these all are our sinusoidals. So sometimes don't confuse, right? In sine wave antanu, right, ila draw chestanu. Okay, don't confuse. ఒక్కోసారి ఇలా కూడా డ్రా చేయొచ్చు, ఒక్కోసారి ఇలా కూడా డ్రా చేయొచ్చు. So it doesn't mean that it is not sine wave. So it is sine wave but shifted. It is sine wave only but shifted. Okay, clear? So don't say that, sir, it is shifted cos అయిపోతుంది కదా. Cos ఏనా, but I have shifted word if I don't use. Shifted word if I don't use, then it is a cos. I said it is shifted sine wave. Obviously cos, but shifted sine wave already. Okay, so this is called sine wave. So sometimes I'll use same representation, please don't confuse. Okay, so expression I have given. What is the expression? Sine, right, omega t, right, and if here I mentioned some a into as, and here some x of t, this is the expression, this is the expression. Right, what is this a? Usually this a is called this one, this peak to peak is called a. Right, So if I say it is 2, it is 2. It is minus 2. If I say here 1, so it is 1 and it is 1. Right, usually sign this value, right, I am representing usually the sign value. Okay, just a minute. Yeah. Usually sign value will be always bounded between this one and another. So keep in mind, always sign value is in between minus 1 and 1. Sign value cannot crosses this. Okay, it cannot crosses this. It will only always minus 1 to 1. But this a we don't know. This may be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever it. So that due to that a, this waveform value will be, right, so 20, 30, 40, 50 as per our requirement. So similarly cos wave. Okay, so we'll discuss more about few more signals in the next class. We have another 3 minutes. Okay, meanwhile, if you have any doubts, I'll try to clarify them. Okay, so I'm stopping the sharing now. If you have any doubts, you can please clarify, you can ask me. Thank you. Doubts? How can you, some people said why it is only 2, 3. So all are exponential, all are rising, right? So I'll take one example. Srihari, Kashyap also said 1, 2, 3, 4. Very good. So Anji said 1, 2, 4. Right. So Srihari, are you there? Are you there, Srihari? Okay. Jyoti,
Yes,
are you
sir.
there, ma? Yeah, Srihari, are you there?
Yes, sir.
Right. Srihari, why you thought only few? Why not all are increasing? Anni perugutunnai leda taggutunnayi kada nana? So why you are thinking that only 1, 2? Right? All are exponential. Okay? Say yes or no.
Yes, sir.
Right. And in the EDC, which topic you are discussing now? EDC class is going on, right? Which topic you are discussing now? PN junction diode? Is it over? Someone please answer. Biasing. PN junction diode characteristics is over?
No, sir.
Right. So in the PN junction diode characteristics, same exponential curves you will get. So that will be like this. That curves will be like this. Okay. So okay, which I have shown in that way only. Don't confuse. So any more doubts, please, you can ask me. So it ends in 1 more minute. Any doubts, you can ask me. No more? Any doubts, you can ask me. No more? Yeah. Please share me the screenshots. Right. Thank you. And one more time I'm telling. So please come regular to the classes. So this irregular things means, right, irregular attendance will be leads to confusion in the subject. So some people who are absent on yesterday, right, so try to, yesterday means last class, come regularly so that only you can understand. Right, few people they are they are continuously absent for classes, so next time it should not happen. And Rushali, Srihari, Pavan, Srinivas, Anji, Ashwini, Shekhar, Naidu, Nana, please, you should represent your name and numbers in 196F1A0436 format. Okay, please, because it's very difficult to me to take the attendance from this. Thank you. We'll see you in the next class. Have a good day.